Now I want to talk about the greatest common factor. And we'll look at numbers first, which should be familiar to you, and then we're going to look at variables. So you look at 10 and 25 and find the greatest common factor. Remember, a factor is a number multiplied by another number to form a product. So the factors of 10 would be 2 and 5. We'll circle the prime numbers there. The factors of 25 would be 5 and 5. So what you have here is you have 2 times 5, and over here you have 5 squared. Well, what you do is you look to see which numbers they have in common. Now, they don't share a 2, so we can cross the 2 out. Now this one, the 10 has 1 5, the 25 has 2 5s. So we take the one with the smallest exponent. So we just take 5, and that's our greatest common factor of 10 and 25. Again, think about what is the greatest number that goes into both 10 and 25, and 5 will be your answer. Now let's look at the greatest common factor of the numbers 18 and 24. Well, if we break down 18, we could do 2 and 9. 2 is a prime factor, so I circle that. 9 breaks down into 3 and 3, so we have 2 times 3 squared. 24 breaks down into 2 and 12, and then 12 breaks down into 2 and 6, and then 6 breaks down into 2 and 3. So I have 2 to the third times 3. So I want to say, what do they have in common? Well, this has 1 2, the 18 does. The 24 has 3 2s. Take the one with the smallest exponent. We'll take that one, so we have 2. They also share 3. This is 3 squared and 3 to the first. We'll take the smallest exponent. We'll take the 3. And then we simply multiply 2 times 3, and that gives us 6. Again, 6 would be the biggest number that goes into both 18 and 24. Now, if we're going to use variables, and I have a note up here that says take the variables with the smallest exponent. So if I say, what's the greatest common factor between x to the 9th, y to the 10th, and x to the 14th, y to the 7th? What I would say is I would simply take the exponents with the smallest number. So we have a 9 and 14. I'll take x to the 9th. We have a 10 and 7. So I'll take y to the 7th. So the GCF of those two would be x to the 9th, y to the 7th. Let's try another one. Try a to the third b squared. Well, actually, let's try a to the third b to the 5th. And a to the 7th b squared. Again, we say, look at the a's. We have a 3 and a 7. So we take the one with the smallest exponent, which is 3. So we have a to the third. 5 and 2, we take the 2, which is b squared. If you want to see this written out, we would say we have 3 a's over here. We have 1, 2, 3, 4, 5 b's. And then over here we have 1, 2, 3, 4, 5, 6, 7 a's and 1, 2 b's. You simply match them up. You say, oh, we have an a here, a there. That's 1. There's 2. There's 3. There's only 3 that match up. So that's why we have a GCF of a to the third. For the b's, okay, here's a pair, there's a pair right there, that's 1 b. Here's a pair right there, that's 2 b's. We wind up with a to the third b squared. Now, what if I add both a number and a variable? So we have 6x to the 9th, y to the 7th, and we have 18 x to the 10th, y to the 3rd. So basically you do the numbers and the variables. You can do them separately if you want. So for the 6, we'll say we have 2 and 3. For 18, we'll go 2 and 9, which separates into 3 and 3. This is 2 times 3. This is 2 times 3 squared. Well, again, we're taking the smallest exponent. So they share a 2. We take the 2. They share 1, 3. We take the 3. 2 times 3 is 6. Again, 6 is the biggest number that goes into both those numbers. For the exponents, we take the smallest ones, 9 and 10. We'll take x to the 9th. Between the 7 and 3, we'll take y to the 3rd. So that's what my GCF would look like, 6x to the 9th, y to the 3rd. Now, what if I gave you this and I said, what's the greatest common factor between 22 and 15? Well, 22 breaks down into 2 and 11. 15 breaks down into 3 and 5. They don't share anything, so you would typically say, well, they don't have a GCF. But if you're thinking well, you'll know that 1 goes into both these numbers. So whenever you think you have a GCF of none, the GCF is always 1. The same is true for variables. What if I said, what's the GCF of x squared and y to the 9th? Since they don't share anything, we would say there's a GCF of 1. Okay? If we had a situation like this where I had 25x squared y to the 8th and 7 a to the 4th y squared, well, the GCF of 25 and 7, they don't have any factors in common, so the GCF would be 1. We would take x, does not share anything on the right side, so we can't use the x. You have y to the 8th and y squared. We take the smallest exponent, y squared. So the y's are taken care of now. And then you say a to the 4th. Well, there's not an a to the 4th on this side, so that's gone. So we're left with 1y squared, which simply equals y squared. A couple more examples and we'll wrap up. What if I gave you this? What if we had x to the 4th, y to the 9th, and a to the 10th, b to the 3rd. Since they don't have anything in common, we're going to say they have a GCF of 1. Number 10, if I have 9, a to the 4th, b squared, and 11, m to the 5th, n, we would say between 9 and 11, they just have a 1. There are no variables in common. There are no a's, b's, m's, or n's that are shared. So we simply say the answer is 1. Last example would be this. If we have three different numbers, or three different, we'll do variables here. We'll say a to the 5th, b to the 3rd, c to the 8th, and then we'll say we have a to the 10th, c to the 4th, and then we have a squared, b to the 11th. Well, let's see if they all share a's. Well, this has a to the 5th, 10th, and squared. We take the smallest one, so it's a squared. Let's see if they share b's. This one has b to the 3rd, right here. There are no b's here, which automatically means they don't have the b's in common. So we cross off the b's. Take a look at the c's. This has a c, this has a c. However, this one does not have a c. So since they don't share a c in common, all they have is a squared. And that's how you do the greatest common factor.